All right, let's get started. I love the difference between the pre-compilers. When there are a few people in here just before 9 o'clock, the class that I teach in here right before this, there are a few people in here, they're on their phone, they're silenced. And then we have the group-oriented project class where everyone is just bustling and talking to each other about their design. There's something about the energy that happens in this class that I appreciate. And it's also the difference an hour makes between 9 a.m. and 10 a.m. I feel like. But here we are. So important announcements. I have the last Sprint 1 peer review up. As you fill that out, please note that the cutoff for that was Sunday night. So whatever has happened since Sunday night, please don't incorporate that into this week's peer review. But it should incorporate everything up to and including your Sprint 1 submission. I should also clarify that as you are doing this, the baseline that you should be using for that effort and technical contribution is what people have communicated with you. So to give you an example, someone has to go to a family funeral. And because they had to do that, they didn't get quite as much done as you would have hoped they would. But they let you know that that was happening. They communicated it plenty in advance. Please don't mark them down for technical contribution because a family member died and they had to deal with that. Things happen. It's the exact same as things in the working world. People can take PTO. You should not be messaging them or forcing them to contribute to a project when they can take paid time off. And that is part of what they are allowed to do. So spread some love in your group and let people have the time and space that they need to be healthy individuals. That said, if it continues to be a problem or they continue to use it as an excuse to not contribute to the project, and they're not pulling their own weight because of decisions that they are making that affect the project, then you should absolutely be marking them down on those peer reviews. So yes, I reached out to everyone for whom that was a concern last week. So if you did not hear from me, there was no downscaling to anything that was associated with your contribution. I'll try to do the same thing this week and make sure that everyone is aware if they are not pulling their weight. But other than that, I've also talked to a few individuals who were self-rating themselves a little bit lower than the rest of their group did, because I think that's also important feedback to note when you feel like I'm being a little harsher on myself than the rest of my group is, recognizing that other people don't quite have the same expectations of you that you have of yourself. Hopefully this goes well. So that's due tonight. I meant to get that up yesterday and then yesterday was really busy. So I apologize, but I would really appreciate it if you can get it in by tonight. If you absolutely can't do that for some reason, just get it in as soon as you can. It's not worth any points. I just use it as feedback for that. But if you do not submit a peer review at all, then I have to assume the worst, that you self-rate yourself a 0 and rate everyone else a 10. That's probably not what you want. So please get it in as soon as you can. And that way I can factor it into the feedback that I give to people. So that midnight is not a strict deadline, but please try to get it in as soon as you can. What else? We have a design meeting tomorrow in our lab. So I'll be talking to every group to try to get a sense of how are you designing and starting Sprint 2 and try to keep you from going off on the wrong foot and making more work for yourselves. Other than that, we have a quiz on Thursday. Study guide is up on Canvas, which is now back up, thank goodness. Yesterday was interesting. Does anyone have any concerns about the Canvas outage from yesterday or how that's affected anyone's preparations or plans for anything? Yeah.
I can't access some of the slides.
I fixed that this morning. Is it still?
Yeah, it's still.
Okay, that's something that I should immediately fix.
Yeah.
Send me a quick reminder email. Just literally send me an email. It doesn't have to have any content in it. The fact that I got an email from you will remind me what this is about. It just jumps to the top of my list. And I'll make sure that I've gone and done everything right. I thought I fixed things. Let's see, anything else before we power forward? I do apologize about the lack of.
Now.
Downloaded,
Yeah.
interesting, interesting, okay.
They figure out why, all that stuff.
I've been so busy that I haven't even had a chance to look into the why.
An intern.
That's really funny, I think I saw on the status updates, they have the status updates on there like, oh, this is the status of the server.
Yeah,
I noticed the last one, but what, it's like their top engineer, like, oh, that's like a yawn. I noticed it said like, at this time, this yawn was right, but then 4 minutes later, the issue was resolved.
yeah. One other note is we've had a few students who have been out sick the last couple of days as well, and so there's a pretty bad cold going throughout the building, and I think that to keep, some of us haven't gotten it yet, and I would love to keep it that way because I'm the kind of person who feels really bad if I rely on every single day of this class meeting. I've shoved so much into this quarter that as soon as something drops out, as soon as I can't teach for a day, kind of the entire quarter falls apart. So I'm trying to keep myself very healthy. If you find yourself sick, please do your best to stay away. It's nothing personal. I just really would, if it affects me, then it affects everyone else. And I will do anything in my power to make sure that at least for my classes, that you have what you need in order to succeed. Remember that you can attend remotely. I am live streaming this to my YouTube channel. I have recordings that are available after the fact. And if you're out sick and you're worried about whatever it is that you would be missing from your group, communicate that with them. And if for some reason they hold that against you, come talk to me and I will make sure that your grade does not suffer due to the fact that you were not able to be here in person because you were sick. I want to make that as easy as possible. So thank you for respecting people around you and for respecting me. Anything else to address? All right. Onwards we go. So just a couple last slides here about stubs and mocks. So that's the last thing that's going to be on the quiz that's on Thursday before we power into a discussion on design patterns. So last we were talking about integration testing, the different ways to integrate. There was the top down, the bottom up, and kind of the meat in the middle or spaghetti integration. And there were pros and cons to all of those approaches. If we use the top down approach, then we're quickly thinking about the design from a UI perspective and not really thinking about the design of the very bottom most specific components within the data representation. And so issues in the data representation become apparent late in the design in ways that might cause an entire refactor of everything that's utilizing that data that's been built to date. On the other hand, there was bottom up that starts with the data representation, but puts off the UI design until the end, the UI integration. And so you might find there are some issues with some assumptions that were made about how the UI is going to come together, that once you start to design the UI, you realize that there's no way to make the UI exactly the way that you want because of some design decisions on the data representation side. There's also the meat in the middle where you kind of start two different processes, one of which is designing the UI, one of which is designing the data, and you kind of meet in the middle. And as you start to integrate those components, you will find that there are some issues with the communication of some assumptions that the UI was making, some assumptions that the data representation was making. But maybe since you're kind of meeting in the middle, that it's going to minimize the total amount of work that has to be done on both sides, since sometimes you have different UI engineers than you have data engineers. So it really depends on the scalability of the company, who's responsible for what, where the anticipated difficulties are going to be, and the better you handle the design from the beginning, the less likely you are to run into those issues as you start to integrate. What can you do before you integrate, though? How can you actually test for and simulate integration before you actually go to integrate? And that is going to be what we talk about with stubs and mocks. So the first one we're going to talk about is a stub. This is something where the code that you write has a dependency. This could be some kind of dependency that someone else in your group is in the process of designing. It could be some kind of library that doesn't exist yet. If you're out in industry and you're trying to create a solution, you know that something is in the process of working and you're going to plug and play with that once it's released. Maybe a company releases an API. This is what we're going to release momentarily once we've fully bug fixed and we're going to release this library to the public. You can put in a stub of something that you're going to use in the future that is not complete or is not ready to test. It's super useful if you are trying to do something like simulate a network or some online connectivity before you have the components ready to interface with the internet. Or if you want to connect to an outside database and maybe you just haven't finished all of the tools to connect to the existing database yet. If there's time or date sensitive code and you want to simulate ahead to what happens when Y2K happens, something of the sort, that if you want to simulate an event that is going to happen in the future. Anytime you're dealing with files or threads, anything that you could emulate. Memory, what happens when I run out of memory? Something like this, if you're using brittle legacy code or systems. So step one to creating a stub is we need to figure out what the dependency is. So what is it that you would need to be simulating the functionality of? It's some resource, some class or object, but that class or object doesn't exist yet. If it isn't an object, then you need to wrap it into one. So you would use some kind of either decorator pattern, something like this, that would allow you to take what's not an object and have an application where the object is just a field in that object. It doesn't necessarily even have to have other functionality other than the accessibility of that field. You just create an object where the field of that is, or the fields of that were the data that you need. So we can imagine now that there is a dependency here between class A and class B with some kind of resource. I love the field yummy data and the method flaky behavior. So you can imagine you have this certain situation where A needs to connect to resource and there's no ability to connect with the resource. So you're going to wrap that behavior up into an object. So objects can have both state and behavior. If you wrap something into an object, it doesn't have to have both. It can have one or the other. It's kind of be a dummy object. So in this case, B is just a dummy object with no state, and it only has the behavior of how it's going to interface with this resource. So that's step one, is wrapping up this behavior. How are we going to interface with resource X? Wrap that up into its own class. We then create an interface for this object. And we're going to extend class B from that interface. So now all of A's code does not work and directly connects to this resource that doesn't exist yet, or it doesn't work the way that you want. Now we change all of A to work with that associated interface. We then write the actual stub. The stub is going to be what has fake data in it that's going to simulate the real data. And it also has the interface with X in ways that is going to simulate interfacing with X in a way that is safe or that emulates that. So as you make B, you can test the associated functionality. Does it communicate with X? As you make the stub, now, even though you don't have access to that data yet, you have fake data, so you can test the functionality of your code, simulating the data that is going to be in X that you either can't access or doesn't exist yet. Does this make sense? So So just using object orientation. This is a very standard kind of design out in the real world. So we call this idea a stub. Some other terms for you, the concept of a seam. The interface between how A talks to the stub. So do you want to do this at construction? We don't necessarily want to do this because this creates a dependency between the class A and the stub B, which you don't necessarily want. It's better to do something via some kind of set resource. This detaches A from the associated stub that's going to do that. This allows you to, at runtime, set the resource to the associated stub so you can connect and disconnect from associated objects at runtime. If you do that within the constructor, then you are forcing that dependency. There's no way that that object can ever have a resource that's not this stub. And that doesn't really allow you any flexibility. So make the object connected at runtime, and then you can connect and disconnect it like a Lego as you run the program. You can also do it just before it's needed. So a method that uses B, now we make the stub for B, and now it interfaces with and talks to the stub for B rather than the flaky resource that has the behavior that you don't necessarily know that doesn't exist yet. So you're just utilizing B's existing interface with the fake data because you don't have access to it yet. So here are the better ways to create your stub. Don't couple them together unnecessarily. That's in general a code smell that I'm not going into, but I should honestly upload some of my 212 slides for those of you who didn't take it, just so that you can peruse some of the bad coding styles. But yeah, coupling things together unnecessarily violates a lot. Any questions, thoughts? All right, that's a stub. All right, a mock is an actual emulated object. So a stub is for a dependency, a mock is for an object that's going to help us test functionality. So the class that's being tested here is on the left. It's communicating with a stubbed object on the right. So this is something that hasn't been created yet. Now, instead of you can either use the stub version where the class under the test says, all right, is this doing what we intended for it to do? Let's test that by communicating with the stub and then writing an assertion, some test that says, is this communication working as intended, yes or no? Note that the stub was just written as kind of a placeholder. On the other hand, you can use a mock object that simulates the full functionality of the object. It's not interfacing with a partially complete something. It is a complete simulation of a particular part of the behavior of an incomplete object. So now we will simulate the mock, and that becomes the assertion for the test. Is the mock doing what was expected due to this communication? So it depends on what's being tested and how that test is happening. This class's behavior is being tested. If you stub it, the class under the test is responsible for passing that test. If you use a mock, then the mock object itself is responsible for passing that test. So the stub has the data, and it gives the data for the class that is being tested. The mock waits to be called. And then we want to make sure that that communication happens in the way that is expected. So take a look at the UMLs here. So A gets fake data, tests its own behavior on that fake data, and either passes or doesn't pass that test. Here, A communicates, uses the behavior to communicate and simulate the behavior of this mock object. And we test, was it called properly from A? Do we get what we expect out of these methods? And the test is asserted under this mock object, with the idea that we're eventually going to sub out this mock object for the completed thing later. This is often used, I'll show you an example of how this can be used to do things like simulate failure. So we create stubs by hand, but mock object frameworks certainly exist and can help with this. Here's what this might look like in code. This is, of course, using JUnit 4 still, now that JUnit 5 is the standard. But we can make a mock object. Then we make our original object. Then we assert that the communication with the mock object is working as expected. Then we see, do we get back what we expected from that mock object? It might seem like if you're making the mock object, why don't you just make the real thing? It turns out that making the mock is usually significantly easier and faster than that to allow you to test the communication between objects. So where is I want to use a particular example here. Yeah, I love this one. So the idea is that we have a log analyzer that is trying to read from a web service. If we get back an error saying that we weren't able to connect or we didn't pull the data that we expected, then the log analyzer sends an email that says this service is broken to some administrator to go fix that. So the idea is the analyzer tries to communicate with the web service. If that fails, then it gets back an error from the web service. And when that happens, we catch that log error and then send an email through an email client to an administrator to go fix the fact that the web service is down or that communication is down or that something is wrong. So what we should do, rather than using an actual web service, is we can stub in a web service that simulates the functionality of the actual web service. All this stub is going to do is basically just return failure. Return that this web service can't be reached. You don't have to have the entire functionality of that web service. It just has that fake data of nothing. It just simulates just that portion. And that allows us to be able to test whether the log analyzer correctly sends the email when this web service fails. The dependency is that the web service is done, that has been written and everything works and is complete. But if we've finished our log analyzer and we want to be able to test our log analyzer, then we can make a very easy part of this web service that just returns the failure that we need to test the log analyzer. That becomes much easier and faster and better than the person who has finished the log analyzer can actually now merge this feature branch into dev and say, I tested it with the stub web service, it's good to go. And now they can move on to doing something else without having this dependency of this log analyzer still being off on its own feature branch for way too long until the web service is complete. Yeah.
I'm a little confused that if you're running your test on your mock object, and your test passes, how do you know that the log analyzer is going to work with the real object?
Because at least the log analyzer is only looking for this particular error. And if all this stuff does is send back that exact error, then the only time that this log analyzer is going to be sending this email is when it receives that. So there is still a potential integration that says that the actual web service doesn't send it, or there's an issue with how they implemented this. But it at least allows you to test whether you're handling it correctly. Are you sending the email via the email sender? And that allows us to test whether the email actually got sent via the email server. So why the test is written for that is we want to actually make sure the email is sent. Not that the log analyzer decided to send the email, but the test is on the actual sender that says, was the email sent? Like, I tell you to send me an email. Does that mean that I received that email? No, it just means that I told you to send the email. The test should be on you. Did you send the email? Because that's the idea that's under test here. So I'm making my objects to do that. And it makes more sense to have the test associated with the mock email sender. And it's just kind of how the stubs and mocks get integrated together to be used together, if that makes sense.
Right, but you know that the mock one can receive the email, or maybe the real one wouldn't receive the email. Unless it's the same.
Yeah, well, the idea is that, yeah, you're only including that functionality to be able to test the log analyzer. You're putting in the integration of the log analyzer doesn't care about anything else in this web service or anything else in this email sender aside from that functionality. So that's all we're going to implement and check is what dependencies does this log analyzer have on these incomplete tasks. I can check off that this works as long as if there's some kind of specification document that we're going off of, some kind of design that ensures that we're all on the same page. I don't need the entirety of the web service. I don't need the entirety of the email sender. I just need the portions of those that interface with the log analyzer. If I can implement just those pieces of that larger process, then I can test the entirety of this object's workflow. Feels like there's a follow-up.
I'm just still a little lost. Like,
How can I explain this better then?
so like the log analyzer, like maybe on the actual email sender, there's a certain flag that you don't know about. And so you don't have that, your log analyzer it's not using that flag. But it's not in your mock sender, is that?
Sure, so that should be in the specification document, some design documents that's going to be part of the design, and that would be part of the dependencies for the log analyzer. Because it's back on 3 or 4 slides ago, it's like step 1, identify the dependencies.
Okay.
That would be one of the dependencies that need to be there, because the person who's doing the log analyzer testing is going to look at these objects, look at the implementation of these objects and say, what are the dependencies in these objects for my log analyzer? And you should be simulating all of those dependencies. And if you're not, then yeah, stuff can still go wrong if you fail to design your specification documents or design documents correctly. If you fail to communicate well with the people who are actually making these objects, there's always stuff that can go wrong. Hope is that you minimize what can go wrong and can actually finish tasks by simulating some of the behavior of how the pieces are interconnected. Does that make sense?
Yeah.
Are there anything else I can clarify? Yeah.
Yeah, I guess if you get to this later in the slides, that's fine too, but like, what place does this have usually in like when the codes start to get like finalized? Is it important to like have that in there always, or is it something that kind of is worked on?
It's more for dependencies. So whenever there's differences in the associated workflow and you want to finalize something that you're working on before you go work on something else, it'd be really annoying if every single member of your development team had a large scale something they were working on their own feature branch. And maybe you even have 5 of them because 4 of them are sitting pending, waiting for someone, the slowest member of your team, to finish the biggest part of the project that everything else is connected to. And they're just being really slow about it. And Sunday night rolls around and things are almost due. And suddenly you have to test that everything that you wrote that you thought was done. And suddenly now it all breaks because of reasons. And it would be nice if there was an issue with what you had made with your smaller components, if you could test that before that other larger connected piece was done. So it's part of the integration workflow. As people start to finish your subtasks, how does that integration happen? How is that communicated? How is that tested? And integration tests are frequently written in terms of stubs and mocks. So starting in sprint 2, there will be the requirements for unit tests. And I'm not going to specify exactly how many tests need to be there, but I'm going to do a pass to see what have you written? Is this a good suite of tests for the vital functionality of your code? I do not expect every single line to have tests written for them. I don't expect it to be completely exhaustive because that would be more work than I think you need to do, at least at this stage. You will continue to write more tests as you develop more in the later sprints, but think also about integration tests. Think about writing stubs and mocks where that would be useful so that you reduce the amount of Sunday night stress as those components are brought together. So you absolutely can utilize stubs and mocks to test things ahead of time. Other questions on this? So now that we've seen how they might work together. I think these slides are a little bit out of order in that we can kind of go back and take a look at what a mock object does now. This does not simulate the entirety of an object. It just takes something that inherits from B, makes a mock object of type B, and just does the little piece of it that is needed. So something like, we're going to pass in a parameter and it returns a value of 0, or just the functionality that we need out of the object to test the functionality of how it interfaces with the object that's using it. So very small amount of functionality. In general, 1 or 2% of the overall functionality of the object. But it's way easier to make that 1 or 2%, get the test out of the way, validate that something works, pass it on, merge it into dev, work on the next thing. Anything else? That's basically all I was planning to cover with stubs and mocks. So we can start to get some experience with those as are needed. But I think the important thing moving forward is knowing what they are and how they're related to each other. How can they be used in tandem to solve a problem? Do we feel like we have some kind of understanding of how to use them together to solve problems? Maybe show a thumbs, feel confident, kind of confident, have no idea what's going on. Somewhere between here and here. I find that to be the case. It doesn't really make a ton of sense the first time you see it. The best thing to do is to go get experience with it. So something for this upcoming sprint that I think all groups can try to advocate for is work together to make a couple of integration tests. Don't try to write integration tests for absolutely everything, but pair program or group program an integration test or two that makes some stubs, makes some mocks, and works together to test the functionality of something, just to get experience working with them. And I think that will help you all to get that understood. Okay. I'm going back to a 212 slide deck for just a little bit. I'm not going to go over the entire strategy pattern. I just want to introduce design patterns for those who haven't seen them quite to the extent that 212 does. So again, getting a sense of who has, how do I want to state this? Who has implemented a design pattern into an existing project that they have written? That's fewer people than have taken 212. That's interesting to me. And some of the hands that are up are kind of like maybe, or so interesting. To me, that's where I think the weakness of 212 was and is as a class, is you implemented some design patterns, but I think the why kind of fell flat in the design of that class, and the benefits that were seen kind of fell flat. So I want to motivate the use of design patterns, and then I want people to get experience actually going through the design process with regards to design patterns. So starting in sprint 3, you will be implementing design patterns into your project. But which design patterns? I will specify one of them that needs to be there, but I will not specify further ones that need to be there. But there will be a requirement that some of them are there. As a group, you will need to decide which design patterns to apply to your project, where they fit, and be able to justify their use. So that's not just make a bunch of singleton, call it good. That is, there should be justification for how each pattern is going to help the future design and development of this application. And you should be able to all justify their inclusion in your project.
We're gonna be completely refactoring our whole project with every sprint.
Not the entire thing, but there will be components of it that will need to be refactored to meet certain requirements. And the better you do in sprint 3 of creating a good design pattern system, the easier sprint 4 will be. So there are some better decisions and some worse decisions with regards to what you might choose to do in sprint 3. So my recommendation for people is when that comes around, that's still in the future, don't worry about it for now. But think about and start thinking about as we're learning about these design patterns, where might they fit in the scope of this project? How could we take whatever it is that the idea is on a particular design pattern as we talk about shapes and colors and some strange abstracted from this project ideas, how do they slot or fit? What are the equivalences in this project? And I think that will help you to be able to have a good discussion as a group about where some of these design patterns might actually fit in your code. But before we do that, I just want to do a quick overview on what they are. Who has never touched a design pattern before at all, or really know too much of what I'm talking about?
Haven't touched it yet.
Sweet. I want to start incorporating that into this class because as 212 goes away and fewer people have taken a design patterns course coming into this course needs to adapt to fit and fill those shoes so that you get experience. I think that code design, refactoring, code smells, and design patterns are some of the more frequent interview questions that are out there for software engineering and development positions. And that is the most likely place that fresh undergraduates go to get their first job. So it is very important that you understand some of these design ideas. And honestly, a lot of the courses in this degree don't touch this as much as they should, in my opinion. So what that means for a lot of students is I can't teach everything, unfortunately. There's going to be some outside of class research and work that needs to be done, just because I think that my own criticism of this degree, we don't cover this material to enough depth to prepare people well for that. So that's my recommendation for people is go study this more outside of the scope of this class. But I'm going to do the best that I can with the time that we have to give you everything that I can. The purpose of design patterns is, in general, to just solve problems that are inherent in object-oriented programming. As some of you may know, object-oriented is only one of many programming paradigms, but it is the most common out in industry, and it's the most common in the current curriculum of just about any university that exists. Everyone learns programming through kind of either a procedural C-like environment, and then you learn about objects. And then from then on, every problem you're thinking about in terms of objects. But that's not the only way to think about programming. There's functional programming, there's data-driven, you get that in 327 with SQL and other database tools, but there are other ways and methods of programming. And object-oriented, if it were the be-all and end-all, then there wouldn't be any other way to program. So design patterns are ways of getting around some of the weaknesses so that you can shove something that might have a better solution in another paradigm to force it to work in an object-oriented paradigm. So the benefits of it, you only have to learn one paradigm as long as you learn the design patterns. The detriments are that the design patterns themselves are they're a workaround, and they feel like a workaround. It feels like overcomplicating the solution. Those of you who did take 212, did you see FSBA's Enterprise Edition? Does that sound familiar? That's something that was gone over for a little bit. Those of you who took it from me, I definitely go over it, but let me at least show it off. We want to do that at the beginning or at the end. Maybe I'll do it at the end, but it's a hilarious program. So does everyone know what FSBA's is from CS1, CS2? So very simple, one method program. You take in an integer. If that integer is divisible by 3 and only 3, print fizz. If it's divisible by 5 and only 5 of these options, print buzz. If it's divisible by both 3 and 5, print fizz buzz. Otherwise, output the same integer that was input. That's it. It's a very common program when you're learning conditionals because you need to check for the 3 and 5 before the 3 and the 5. So it tells you kind of the ordering of conditionals and how if you check for 3 first, you're not catching the 3 and 5 case because it will be grabbed by the 3 case. So ordering of that is important. How many lines would it take you to write this in Java? Something single digit or low double digit if you're putting curly braces on their own lines, but it's very few. If you decided, you know what, this is a very simple idea, let's overcomplicate it as much as possible by incorporating as many design patterns as we can possibly throw into FizzBuzz, you end up with this beautiful, disgusting abomination. So inside of our source, you can imagine just doing this in one main method, right? It's just one call. And of course, there are tests written for it, but otherwise, we have the implementation and the interfaces, as you would expect. Inside of the implementations, we have main, standard, a program for the constants. We have all of the associated factory patterns, parameters, printers, strategies, string returners, visitors. Inside of each of these, for instance, in the factories, we have the buzz strategy factory, the buzz string printer factory, the buzz string returner factory, the enterprise grade FizzBuzz solution strategy factory. It just goes on. It is so overly complicated that it's disgusting to even think about. So before even discussing design patterns in the first place, I find it important to talk about this is not just a solution. Just because you can shove a design pattern into a solution and it fits does not mean that it's an improvement. There is a design that goes on with regards to should I use this design pattern or not in ways that is the future of the design of this going to, is this going to save me time or is this going to create an unnecessary headache? So there are appropriate uses of design patterns and very inappropriate uses of design patterns. Every single design pattern used in FizzBuzz Enterprise Edition is an unnecessary design pattern because it is so simple and so easy to do without design patterns. So I use that as a big warning before even talking about it. There are places that they fit, and they absolutely do fit. You should know how to use them. But you should also know when not to use them, because that is just as important. All right. 3 major categories of design patterns it's worth thinking about. The creational design patterns that focus on how objects are created. So these can either work and take place completely within object construction. General goals of creational patterns. We want to be able to incorporate and increase the flexibility of that object creation, have the ability to reuse our code in other places. So we want to be calling the same constructors whenever we can. We don't want to have 7 different constructors for the same object if we don't need 7 different constructors, especially different constructors with conditionals within them that you can see that the code can possibly explode in complexity if there are a lot of conditionals associated with object construction. So this helps with the organizing of the structure of object creation such that when new requirements come in, you can just modify the existing structure rather than having to gut the structure and rewrite all of your constructors from scratch. So if done well, creational design patterns save you time in the long run at the cost of some design for your constructors in the first place. We have structural. So structural just is dealing a lot with when we have objects that are made up of objects that are made up of objects and the interrelations between objects. Then as we do this, there are some fairly common problems that arise that if you can recognize the problem, you can easily see that a design pattern could fix that problem. The goal with this as again, new requirements come in from a client, you end up refactoring something changes, some of your code becomes legacy and needs to be replaced with new code. It's easier to perform surgery on your code because so few changes are required because You've thought about the flexibility of your structures, you've thought about the efficiency of your structures. So as new requirements come to light, minimal changes are needed. Behavioral, this is just communication between objects. So when objects are actually trying to communicate with each other, what happens? Who's responsible for what? If multiple objects can do the same thing or can pass along associated chains of responsibility, then how is that chain handled? How do we know where to forward the associated responsibility based on the information that you receive? So we want to, as we do this, encapsulation is incredibly important. Hopefully you've had solid background in encapsulation. Anyone want to briefly summarize why encapsulation is super important? Take a stab at that. Yeah.
I could try to describe it. It was like when you encapsulate like something with code, like a method, it's like using something that another method would also kind of already incorporate to kind of like saving yourself time with. So like, oh, I gotta constantly do this for everything versus you encapsulate it and kind of simplifies that workflow a little bit.
Okay. I like to think of it as mostly security. Yeah.
The data and the methods that interact with those data are all encapsulated in the class.
Yeah. So anything that's going to modify the class itself comes from within the class. Any behavior for that is defined within the class. How this can change or be modified is specified within the class. You can think of it like the class defines the permission of what is allowed to be done to it. As soon as you allow some outside object to modify the class in the way that the class wasn't designed for, that violates encapsulation. Something like, by being here, you all gave me permission to give you a grade for this class. If I try to give you a grade for a class for which I am not the professor, that is outside my responsibility. That's outside of what I should be able to do to you. Imagine that I could go into your transcript and just change your grades for classes that you didn't take with me because I don't like you. Is that something that should be allowed in a grade system at a university? That's something that needs to be encapsulated inside of a system where there are strict rules and definitions for how grades are assigned and how grades are changed. As soon as any one entity can modify that in a way that's not intended, you violate that. So as a designer, your responsibility is to ensure whenever you create an object that all of its fields are private, can only be modified by methods that are within that class that modify it in the ways that are specified within those methods. Otherwise, you have big security risks. Something outside of the class can change the class, without the class being aware that that was changed. That creates all sorts of nightmares, as you might be able to imagine. So this is the caution. I've actually already done this by saying that they're not appropriate for every situation. Here's where I want to go talk about FSBO's Enterprise Edition. They're not efficient. By incorporating design patterns into your code, you're frequently slowing things down. And the trade-off that you get for slowing things down is increased flexibility in future design. It's going to be less work when you go have to make associated changes in the future. But you don't want to do that unless you want to have that level of flexibility in the future. So there are some things that you want to go through that work for, and some things that you don't. You should have a good reason to apply a design pattern. You should be able to justify every single pattern that you put in any piece of code that you write a pattern for. And just in general, critical thinking is everything. There are no rules, plug and play that just fit with design pattern. I don't think there are a few of them, but in general, you should be aware of the why behind every decision you make that separates someone who has to be told what to do from someone who can make an intelligent decision on their own. That separates a code monkey from a leader. bunch of 212 types of that. So that's kind of just, this is it with regards to what I wanted to go into for introducing design patterns. So this is a natural place to, I think, stop for the day. We will have lab tomorrow, quiz on Thursday, we'll come back on Monday. And I will go through Refactoring Guru and try to go pattern by pattern and talk about when we would use each, or why, what they're trying to solve, and show you how to use the sites to learn the most that you can out of these chapters. That's what we're headed. Office hours starting now. If anyone needs anything, you know what?